Bismillahirrahmanirrahim. Assalamu alaikum. This is me Daud Salim and welcome to you all in my YouTube channel Math Club. It is going to be my first video on the complex analysis subject. In this video I will tell you that what is complex numbers. Also I will let you know that the historical history of complex number. It will be my first topic, and then I will let you know that what is an imaginary unit. Actually in this video I will target like how complex number came into being. It's gonna be my first target, and inshallah in the next video I will tell you that why do we study complex numbers even though we are dealing in the real world with the real numbers only. If we are doing shopping, so we do use the real numbers only, we don't use the complex numbers. So why do we study this subject? So before starting the video, it is request to you that please do subscribe my YouTube channel Math Club and also press the bell icon so you can get the upcoming notifications of my next video. Alright, so let us start the video. My subject name is complex analysis. In the historical history, I would like to tell you that not one person invented complex numbers. Like complex numbers, they were not invented by a single person. But the controversies surrounding the use of these numbers existed in the 16th century. You know that in the 16th century, mostly like mathematician, it was introduced for the first time. So mostly mathematician didn't know that how to use complex numbers. So there were so many controversies in the mathematician, and there were lots of contradictions as well. In their quest means search, and their search to solve polynomial equations. Like I assume that you know polynomial equation, and let me tell you what are the polynomial equations. Like if we are having a variable, here I used a polynomial equation x square plus 2x plus 2 is equal to 0. So polynomial means like if we are having the power of the equation in the whole numbers, like the power of the variable, sorry, or any number, we are having the power in whole number. So just we call them polynomial equations or polynomial expression. Like here the 2 is the power, so 2 is also a whole number. Here the power is 1, so 1 is also a whole number, you can say like. And also we are having the power of 2 is 1, so it is also a whole number. That's why it is a polynomial equation. So in their search to solve polynomial equations, like we are having a lots of polynomial equations, which answers in their answer we get like this term square root minus 1. So in their quest to solve polynomial equations by formulas involving radicals mean the square root sign symbol, and math were forced to admit that there were other kinds of numbers besides positive integers. Because like if you do solve this polynomial equation, so we get the answer. In the answer we get like square root of minus 1. So when mathematicians, they were dealing for the first time such kind of equations, so they saw that there exists minus 1 into root or minus 2 minus 3, like any kind of, but there were negative in the square root. So they become very depressed that they saw such kind of number for the first time. So that is why it is written that in math were forced to admit that there were other kind of numbers beside the positive integers. Like positive integers are 1, 2, 3 and up to so on. So like besides them, except them, there are also some numbers like which are the negative of square root, which are in the in the square root, and they are negative numbers. Like the minus 1, it's also integer, negative integer, but it is in the square root. So they saw such numbers for the first time. So mathematician becomes so depressed. Like equations such as x square plus 2x plus 2 is equal to 2. Let's say that this is equation number star. If you do solve this equation, then the solution of equation number star is given by using the quadratic formula, because we can't solve this equation through factorization. Alright, so we have quadratic formula, that is x is equal to minus b plus minus square root of b square minus 4ac divided by 2a. We can just derive this formula by the completing square method as well. Inshallah I will do sometime I will just derive this formula as well. So now let us move towards our topic, that is here a is equal to 1 because the coefficient of x square is 1, b is equal to 2, the coefficient of x is 2 here, and c is equal to 2, like c is a constant. Put all these a, b, c, the value of a, b, c in the equation number 1, we get that x is equal to minus 2 because b's value is minus 2, and plus minus square root of b square minus 4ac, so minus 4 is and 1 because the value of a is 1 and the value of c is 2, divided by 2. After doing the calculation like this, these are just simple calculation, we get the value of x is minus 1 plus under root or square root of minus 1 and minus 1 minus square root of minus 1. So these minus 1, these were quite horrible for the mathematician for the first time. Like here it is also written, so mathematical scholar or mathematician, because everyone knew that there are no numbers such as, like for the first time imagining such kind of number, it was quite strange because no one knew that there exists such kind of numbers as well, minus 1, minus 2, minus 3, minus 4 in the square root. So whose square is negative, square root is negative, sorry, square root is negative. Such number exist only in one's imagination, like these numbers weren't exist in the real life, in the real world we don't have such kind of numbers. So in the 16th century, I'm just talking about in the 16th century, so mathematician found it strange and mathematician thought that these numbers can be exist in the imagination of a person only. Okay, so but in the 18th century, like we know that in the complex number mostly work is done by Gauss, he was a mathematician. So in the 18th century the number concept took an evolutionary step forward when the German mathematician Carl Friedrich Gauss put the so-called imaginary numbers or complex numbers, like he just gave them the name complex numbers or imaginary numbers, and he did a lot of work in the field of complex numbers. Later we will discuss them as well, as it was the beginning. Like in the 18th century complex number was introduced in the 16th century, but mostly mathematicians did work on them, but no one like found a clear result. But in the 18th century, like in 18th century German mathematician Gauss, he just did some work on the complex number as it was the beginning and treating them as the extension of the real numbers. Like he just gave the idea like we can treat complex numbers as like parallel to the real numbers. We can't just treat them as real numbers because we do have a lot of difference, like, and the set of complex numbers is far bigger than the set of real numbers as well, because in the complex numbers we do have real numbers as well. In the definition you will get the idea, but you know that Gauss, like he did a lot of work in the field of complex numbers, and he just like in this subject we will deal with them, like how complex number were treated as real number, as like parallel to the real numbers. Alright, so it was a quite history of complex number, and now proceeding towards the next topic, that is imaginary unit. What is imaginary unit? Actually, imaginary unit was this, like the naming of the square root of minus 1. After gaining a wide respect through the creative work of Carl Friedrich Gauss and the French mathematician Augustin Louis Cauchy, he was also one of the greatest mathematicians who worked in the field of complex number. He also gave some Cauchy-Riemann equations, and he also did prove a theorem on basis of that equations as well. Inshallah later we will discuss them because it's the first class and it's the first lecture. So in the first lecture I will just deal some basic definition and some basic headings. Okay, so in the field of complex number, two scientists, they did a lot of work. One was Gauss and the other was Cauchy. Like the Augustin Louis Cauchy, his complete name was this, and the unfortunate name imaginary, like this is not quite a good name, has survived down through the centuries. Like this name for the complex numbers, this name like the imaginary number, this name lasts for 2 centuries. Like for the first time in 16th century the complex number was introduced, so till 18th century its name was imaginary numbers, or just they call square root of -1 imaginary, like they don't have the proper answer and they didn't know how to use them. So this name survived through the century by means that from 16th century to 18th century the name was imaginary. Then the symbol iota was originally used. Iota, this symbol names iota and it's written as like I, but it's quite, yes, so this is its name is iota, its pronunciation is iota, was originally used as a disguise for the horrible symbol. Like this symbol was quite horrible, quite strange for the mathematician, and disguise means like changing its shape. Like we just called that it is the name of this number, like -1, its name is iota. In the 18th century they kept the name iota. Square root of -1, its name was iota. In the 16th century they just gave in the 18th century the mathematicians like Gauss and the other whose name is Cauchy, he just gave them the name iota. It's the name, it's not the value. And later on, like iota is the imaginary unit, iota became the imaginary unit and defined it by the property iota square is equal to -1. If we apply square on both sides, so this square root will be cancelled and the value of iota square will be equal to -1. Then my last topic, and it's the first topic of this subject as well, because the above topics, like the history introduction, historical introduction and imaginary unit, these were the topics in the history, and it is the first topic of this subject. Complex numbers. Its definition is: a complex number is any number of the form z is equal to a plus iota b, where a and b are the real numbers and iota is the imaginary unit. Like a will be also a real number, and b it will also be a real number, and iota is the imaginary unit, or simply iota b together. Like if we just bring them together, iota and b together, it called the imaginary part. The example of complex numbers are 3 plus 2 iota. Like these are the general examples of particular examples of complex numbers: 3 plus 2 iota, 0 plus 1 iota, 5 plus 2 iota, only iota. It's also the example of complex numbers. So in this start of the video, as I told you that set of real numbers, like set of real numbers, it is far smaller than the set of complex numbers, because in complex number, in the definition, we are just claiming that we can write them as z is equal to a plus iota b, where a is the real part. So a is also the real part and b is also the real part, but here we are having another number, you can say that is another unit, imaginary iota. So it is an imaginary, like there in complex number we do have real numbers as well. Like we in the definition we just said that this is the definition, the mathematical form of the definition of complex number: a is the real part or b is the real part. So in complex number we do have real numbers as well, and iota it is more, and it is more in the complex number. So that is why here is also iota including in these numbers. So that is why set of complex numbers is far bigger than the set of real numbers. Alright, so it was all about my today's topic, complex numbers and its historical history. In the next video I will deal with the topic that why do we study complex numbers. So inshallah in the next video I will let you know from that why do we study complex numbers. So until then, if you do have any question, any query in the today's topic, so kindly ask me in the comment section. I will definitely answer you, and until then, stay blessed. Okay, bye bye.